Hello, this presentation is for World Congress on Internet Security WorldCIS 2015. My paper was titled Random Walk with Jumps, a new query search method based on analyzing Gnutella Protocol. My name is Kholoud Althubaiti, teacher assistant at Taif University in Saudi Arabia. The paper presented the measurements and analysis of three methods of Gnutella: float, random walk, and random walk with neighbor table. The measurements were driven by two primary questions: which of the three methods has the least average hops and or number of failures, and which has the highest? What is the impact of expanding the network on the success of the query? In light of the outcomes, the study proposed a new query search method for Gnutella that improves the current code and makes it more scalable. The new method is called random walk with jumps. It's well known that a good search method must have a small number of failures and minimum number of hops. For example, suppose maximum hops are 3, then there are two cases. First case, file will be found, which means success. If the file is found after 2 hops, that would be better than 3 hops, because minimum hops will decrease search time. As we see in the figure, it hops 3 times and asks for the file 3 times too, which is good, but 2 hops is still better because it will minimize the time of search. Second case, file will not be found, which means failure. If the file is not found in 3 hops, that means the search failed. The study focused on the number of run failures and average hops by taking into account the average of all runs. The number of nodes we are searching through is from 10,000 to 100,000. Some of the values have been fixed in an effort to establish a correct result. The maximum number of neighbors is 10, the number of files is 9,000, with maximum number for each node between 5 and 15 and 50, and maximum hop per query is 7. In the presentation examples, maximum hop we suppose it's 3 because it's easier. Flooding distributes the file across every graph in a network. This algorithm works by applying the following steps. One of the nodes requests a file. Each node works as a sender and receiver except the file node. The first node, each node tries to send all messages to all its neighbors except the source of the message. So, in the very end, the querying node will absolutely receive its requested file. As you see in the graph, all the nodes will work as sender and receiver. Random walk algorithm is popular alternative to flooding. It distributes the file to a random walker, which chooses a random node to walk to. The querying node sends queries to a randomly selected neighbor. Each random walker has a hop count. If the file is not found, the node checks the hop count. If the hop count bigger than 0, it decrements by 1 and forward the query to a randomly chosen neighbor. If count equals 0, the query is not forwarded, which means run failed. As you see in the figure, the route will look for neighbors and choose one randomly. Count here is returned to number of hops. As I told you before in example, it's 3 hops. At first count will be 3, then hop and decrement by 1. And ask for file. If not found, will hop and decrement again and ask for file. If it's found, so that will return success. If it's not found, like this, it will hop and decrement and ask for file. If file found, the search succeed. If not found, that means search failed. Last algorithm is random walk with neighbors table algorithm. This is similar to ordinary random walk. This method checks to see if its neighbors list has the desired file within them. If so, the neighbors walk to that neighbor. If it's not, randomly chosen. Two cases to walk: random walk, represented by red arrow, or blind walk, which chosen from the table, which represented by blue arrow. For instance, here the root will check its neighbors list to search the file. If file found, it go to that neighbor, not randomly work, it's planned work. And file will found, which means success. Second case, if the root checks its neighbor list and not found the file, it will walk randomly. Then the next node will check its table and search for file. If file found, that means it will walk planned walk. It's not found, will walk randomly. Here it's found, so it's planned work to the neighbor. Here is the result of analyzes number of filers. As you see in this figure, in general, the result of the analysis that number of filers is the least in flooding compared to random walk and random walk with neighbors table, because flood sending message for all neighbors, it should be the lowest number of failures. But about number of hops, as you see in these numbers, flooding has the lowest number of failures as shown before, but at the same time it also has the highest average of hops. Random walk with neighbor table shows the lowest average hops, so we need to find an algorithm get the lowest number of failures and hops in the best case. So we proposed a new query search method which called random walk with jumps. This algorithm can be considered random walk search algorithm in which that random walk makes jump. The querying node is sending the number of queries to a randomly selected neighbor. It chooses a random length to jump. If the jump length bigger than 0, it passes to another random neighbor and decrements the length by 1. If jump equals 0, it stops passing and searches for the file in the current node. This step is considered as a single random walk. If we suppose we have 3 jumps, every hop, that means it will jump to get 0. Then ask for file, is it available or not? If not, the hop count will decrement it by 0, then jump 3 times and ask for file. It's different than last algorithm. It's search in wide area. As you see, it will jump, then after 3 jump, ask for file and jump and ask for file. Here is the comparison of that 3 methods and our new method. The result of the analysis that number of failures is the least in flooding compared to random walk and random walk with neighbors table. But random walk with jumps it make good. About the average number of hops, as you see in this figure, the random walk with jumps algorithm has the best score in average hops because it jumps first, then it's asked for a specific file. Because the internet is wide network, so jump first, easier to find the file. This method beats the best values in the 3 methods, which are the number of failures as flooding and average hop as random walk and random walk with neighbors table. So it's considered. Thank you for your listening. For any question, contact me at kholoud.k.cs@outlook.sa.